Right. Let's start the discussion of Mind Booster, paper number 2, right? Okay, question number 1. The equation of state, some gases can be explained as, you are given P plus A over V squared minus B, no? Equal RT. Right. This is the mentioned equation. P is pressure, V is volume, R is universal gas constant. We don't identify exactly whether the value of R, no, it's universal gas constant mentioned one. Just forget it. T is absolute temperature. We don't use the dimension of absolute temperature as well. No. Find the dimensions of A and B. Let's see. It's very easy. How? You can see this one subtracted with this one, right? Here A, we subtracted with B. Then they are definitely similar quantities. Subtraction as well addition, similar quantities. Then dimension of B should be L cube, its volume, right? This is the dimension of B. Clear. And this one, P added with A over V squared, right? Then dimensionally, this and this should be same. Reason, addition or subtraction take place under same physical quantities. Clear with that? Clear, right? Then simplify this one. Then need A, no? A dimensionally equal with pressure. M, L minus 1, T minus 2, volume, L3 to the power of 2, no? Then dimension of A becomes M, L minus 1, L minus L plus 6, L to the power 5, T to the power minus 2. Right. These two are the dimensions of A and B. Can you complete now? Quick as possible. Then question number 1 answers should be B L cube, A M L to the power 5, T to the power 2, right? Okay. This one, question number 1. Now, can we consider question number 2? Second question. Right, this one finish. Second question. Number of particles. See, question number 2. How to manage it? You are given an equation. N equal minus D. Denominator we have x2 minus x1. Numerator we have n2 minus n1. Okay. Right, Buddha? Number of particles crossing a unit area. Number of particles crossing a unit area perpendicular to axis per unit time. Let's see, M represented number of particles per unit area. Per unit area. Area to be the numerical denominator one. Per unit time. It's here also time now. When we take an equation according to the given statement, we have to say N should be the number of particles per unit area, per divided by area, per time, again divided by time. Then n consists with the dimension, number of particles, no dimension, area, 1 over L squared, 1 over T. Then dimension of n becomes L minus 2, T minus 1. First of all, we have to identify about the dimension of the given quantity of n as well. N1 and N2 are number of particles per unit volume. N1 and N2. N1 as well, N2 dimensionally, number of particles per unit, per divided by volume. Is that clear? Per unit volume. Then dimension of N1 and N2 becomes L cube. It's L minus 3. What's the need? You are asked to find dimension of capital D with the equal of x1 and x2 and x2 distances, right? Per unit time for x1 and x2 distances. Find the dimension of D. D dimensions. Can we check? N, we can substitute L minus 2, T minus 1. D to be found. N2 minus N1 is L minus 3, x1 minus x2 across x1 and x2 means length, right? Okay, then L minus 2 either side, minus 2 cancel, minus 1 available. This one comes down, cross multiplication. L minus 1 comes down, L plus 1. Plus 1 plus 1, 2, 2 cross multiplication. Then D dimension becomes L to the power of 2 and T to the power of minus 1. Right. Can you correct the answer? If you wrote this answer, that would be perfect, right? Okay. This is the accurate way of taking the answer. Right. Complete this one too. Question number 2 completed. Right. Number 3. We are going to consider third question. Question number 3. Right. Third one. In the relation you are given, third question consists with the relation. It's P equal alpha over beta E to the power of alpha Z over E. This is the relationship, right? Where P is pressure, Z is distance, capital E is energy. Simple E is dimensionless. Find the dimension of beta. So this is dimensionless mention. Dimensionless. Then this one and this one to be similar. Exactly, dimension of P same as dimension of alpha over beta. You are asked to find beta, no? To find beta's dimension, first of all, you have to find dimension of alpha. It is considered right here. Let's see. E to the power alpha Z over E. Then what do you say about this one? The power of a numerical value. Power of a given value. Power of a numerical value. Power is like square, cube, half of power, 1/3 power, 1/4 power, fourth power. It's a digit. Then here, dimensionless. What do you mean that? Power of a physical quantity is a numerical value. It doesn't have dimension. Clear? Yes. Then you can say now alpha Z over E, no dimensions. No dimensions. So you can say now E goes to here. They need alpha now. Alpha is energy divided by Z, right? Energy. We have the dimension M, L squared T minus 2, Z, L, L cancel, it MT minus 2, right? ML minus MLT minus 2. 1L present, MLT minus 2. Then this is the dimension of alpha. Can we take this one with this one? ML minus 1, T minus 2 equate alpha divided by beta. Alpha known, we found alpha. ML T minus 2 over beta. They need the dimension of beta. So subjecting beta, M cancel. T minus 2 cancel. L. Beta goes to here. L minus 1 comes down, goes up. L to the power of 2. Then beta dimension is M0, L2, T0, which means L to the power of 2. It is the area, right? Okay. Question number 3 completed. Can we check number 4? In this case, first of all, we have to find alpha. No? Second of all, we have to take the next application to find about beta. Okay. Right. Question number 4. Fourth question. The velocity v of a particle is given in terms of, question number 4, velocity is written at plus b over t plus c, no? Where t is time, v is velocity. And you are asked to identify A, B, C. You should identify A, B, and C, right? Okay, then let's see. These two added, right? Then time and term C should have same dimension. C dimensionally same as T. Then C is T. Dimension of C is T. They need the dimension of A, B, and C. Next one, B over T as well B over C, similar to each function like this. Let's say they are having same dimensions. No, you can say once V dimensionally same as AT, LT minus 1 A, its T comes down and goes up. A dimensionally we have acceleration as well. V dimensionally we have B over T. Yes. Then B becomes dimensionally LT minus 1 cross multiplication T, TT minus cancel, it becomes L, right? Yes, then ABC, dimensionally we have A acceleration, B length, C time, right? Easy, very easy. Okay, can we complete this one? Question number 5. Which of the following quantities having the same dimensions, similar dimensions, quantities to be identified, right? Okay. Can we manage one by one? Similar. Okay. What are the similar there? We can say Young's modulus and pressure, no? You are given first one, Young's modulus. Number 5, Young's modulus. Young's modulus and pressure, similar. You have to write them, right? At the given space. Next one. Momentum and impulse, similar. Impulse and momentum. Next one we can say work, similar with energy, dimensionally similar with torque, no? With the torque similar. And we can say spring constant and surface tension. Dimensionally similar according to the given. Right, similar dimension for coefficient of viscosity, we don't identify, no? Right, then they are the similar dimensions. Can we write them here? ml minus 1 t minus 2 here, ml t minus 1 here, ml minus 1 t minus ml2 t minus 2, spring constant mt minus 2. Done. Right, checking the last one. Check for the dimensional validity of the expression H equal K sigma, where H is rise of liquid, sigma is surface tension, rho is density, radius is r, g gravitational acceleration, K being a dimensionless constant, right? K is dimensionless constant. Right. Can we check now? K is dimensionless constant, right? H equal K sigma over R rho G. Checking the dimensional validity. We are considering left hand side dimensions. Left hand side we have H. Dimension of H is L. Then considering right hand side dimensions, T sigma over R rho G. Substitution. Sigma surface tension mt minus 2 R L rho ml minus 3 G LT minus 2. Right. Simplify. M cancel. T minus 2 cancel. Here we have L1, L2, L minus 1 available goes up, it becomes L. Then you have to say left side and right side similar dimensions available. Then both side dimensions correct. Then equation is dimensionally correct, right? Can we note down? Equation is dimensionally correct. Okay, Buddha. Next week you will have Mind Booster third paper. Then week by week we will develop with the number of questions as well, number of deviation of the questions throughout the entire studied syllabus, right? Okay, that's enough for this week, right? Okay.